Hello students, welcome to the new lecture. In this lecture number 12, we'll discuss the fill in the blanks questions of transformers. Let us start with the first question. Transformer operates on dash only. So transformer operates on AC power supply. So answer is AC. Second question. If rated DC voltage is applied instead of the AC to the primary winding of the transformer, then dash winding of the transformer will burn. So primary winding is going to burn. So if we apply DC power supply to the primary winding, then primary winding is going to burn. It works on AC only. Primary winding is going to burn. Next, third question. The iron core in a transformer provides a dash path to the main flux. The purpose of the core of the transformer is to give the path for the flux. So it gives the low reluctance path. So low reluctance means flux development is going to be easier. So it gives the low reluctance path to the main flux. The type of value of the flux involved in the EMF equation for a transformer. In the EMF equation of the transformer, what kind of flux is involved? Peak value of the flux or maximum value of the flux is going to be involved. The no load current in a transformer lags behind the applied voltage by 75 degrees. Next, question number 6. If the supply frequency of a transformer is increased, so we are increasing the supply frequency and we are keeping the supply voltage equal to constant. V value we are keeping the constant. Then the magnetizing component becomes what? So magnetizing component is inversely proportional to the frequency. As the frequency increases, magnetizing component value is going to decrease. And what about the core loss component? Core loss component means like eddy current loss or hysteresis loss components. As the frequency increases, core loss component is going to increase. So magnetizing component decreases, core loss component is going to increases. This increases. Natural air cooling is used for transformers rating up to 5 to 10 kVA. So natural cooling is used up to what rating? It's up to 5 to 10 kVA. 5 to 10 kVA transformers. Question number 8. Importance of breather in a transformer is to, what is the use of the breather in the transformer? To observe the humidity, moisture, to observe moisture. Next, the no load current of a single phase transformer consists of dash and dash component. I naught is going to have the I mu magnetizing component and IW iron loss component. It will be having magnetizing component and as well as iron loss component. Next, question number 10. If Pi be the iron loss, PC be the copper loss on full load, then the condition for obtaining the maximum efficiency at 3 by 4th load. So we know the maximum efficiency is equal to iron loss equal to copper loss or copper loss is equal to iron loss. So at the 3 by 4th load, copper loss becomes what? 3 by 4 whole square PCU, that is 9 by 16 PCU. But whereas iron loss will be Pi only. At 3 by 4th also there is no change in the iron loss. But what about the copper loss? Copper loss becomes 9 by 16 PCU. So this is the condition for maximum efficiency at 3 by 4th load. Iron loss equal to 9 by 16 copper loss, or copper loss equal to 16 by 9 iron loss, or we can also say copper loss equal to 16 by 9 iron loss. A transformer can have zero regulation at a leading power factor. At leading power factor only we can have the zero regulation in the transformer. Next, question number 12. In a transformer, core is laminated to reduce the eddy current loss. to reduce the eddy current loss, transformer core is going to be laminated. Condition for maximum efficiency of transformer. So constant losses equal to variable losses. This is a condition for efficiency in transformer, maximum efficiency in transformer. Constant losses equal to variable losses, or iron losses equal to copper losses. Next, what is the efficiency of the transformer? Efficiency of the transformer is output power by input power, or we can say output power in terms of output power divided by input power. I can write it in terms of output power plus losses, or output power I can write it as P input minus losses divided by P input. This is a transformer efficiency formula. If you want in percentage, you should multiply with 100. Efficiency of a transformer is maximum when constant losses equal to variable losses. To reduce the eddy current losses in the transformer, dash is added to the steel. Silica is added to the steel. The core losses in a transformer consist of dash and dash losses. Core losses. There are two types of core losses. One is hysteresis loss and other one is eddy current loss. Two losses exist in the core losses in the transformer. One is hysteresis loss and other one is eddy current loss. The voltage regulation of a transformer can be determined by conducting dash and dash test, open circuit test and short circuit tests. Next, the regulation of a transformer is 0 when the power factor is leading power factor. When the power factor is leading power factor, we can have the voltage regulation 0. There is a chance of getting voltage regulation 0. The open circuit test on transformer gives information of iron losses. Question number 21. A transformer has full load copper loss of 400 watts. The copper loss at half load will be. So the copper losses formula at one particular load is N square into PCU. N square is N is representing the load. Half load means N is equal to 1 by 2. So 1 by 2 whole square into, this is the full load copper loss. This is nothing but what? Full load copper loss. So 1 by 4 into full load copper loss is how much? 400. So 100 watts. When the load is becoming half, copper losses are becoming from 400 to 100 watts. Answer is how much? 100 watts. Next, the short circuit test is conducted to determine is copper losses. Short circuit test will give us the information of copper losses. Dash is performed to determine the copper losses in a transformer. SC test is, short circuit test is performed on transformer to find out the copper losses. Next, question number 24. A transformer steps up the voltage by factor of 100. The ratio of current in the primary to the secondaries. So transformer is stepping up the voltage by factor of 100 means V2 is equal to, we can say 100 V1, or we can say V2 by V1 is equal to 100. And here what is our asked ratio of current in the primary to the secondary? What is the value of I1 by I2 is asked. We know the inverse relation is there between voltage and current. V2 by V1 value is equal to what? I1 by I2. So here V2 by V1 is how much? 100. That is equal to I1 by I2. So 100 is equal to I1 by I2. So I1 by I2 value is equal to how much? 100. So it is 100 by 1, or 100 is to 1. Next, the chemical used in the breather is, what chemical is used? Silica gel is used in the breather. The transformation ratio of a transformer. Transformation ratio of transformer is what? E2 by E1 or N2 by N1. Turns ratio means N1 by N2. Transformation ratio means N2 by N1. The primary ampere turns means N1 I1 is dash to the secondary ampere turns N2 I2. So both are equal. Primary ampere turns N1 I1 is equal to secondary ampere turns N2 I2. The phasor position of magnetizing current component of an ideal transformer in the phasor diagram. It lags the applied voltage by 90 degrees. As the transformer is ideal transformer, there is no losses in the transformer. So this I mu is going to lagging the applied voltage by 90 degrees. Lags behind the applied voltage by 90 degrees. So these are the few fill in the blanks questions which were asked in the Jntuh bit paper questions. Thank you.